goes there, that 1 goes there. So that ends up being Li2CO3. Then moving on to your third rule. Oh, I didn't actually look if this one was balanced, but if you look closely, you'll actually see that everything balances out. There's 2 lithiums on both sides. There are 4 oxygens, 1 carbon, 2 hydrogens, so this actually balances out nicely. Okay, then on to rule 3. Rule 3 says that an acid plus a metal hydroxide gives you a salt. And this is actually not difficult because it gives you exactly the same products as the previous rule, so it's not difficult to memorize. So let's use phosphoric acid, which is H3PO4, which is one of your weak acids, plus let's use magnesium hydroxide. Now the reason my hydroxide is written in a bracket like that is because magnesium's charge is +2 and hydroxide is -1. So when I cross multiply, it gives me that. So that ends up giving me my salt. And you can do this every time. You can highlight your metal on your second part of your negative part of your acid. So it gives me Mg phosphate. We'll do the cross multiplying now. So Mg's charge is +2. Phosphate's charge, again, a compound ion that we need to memorize, is -3. If you cross multiply, it gives me Mg3PO42. Now you remember hopefully that when I multiply a compound ion by a number, I need to put it in a bracket. Otherwise, it's going to look like 42, or I can't just multiply by the oxygen and get 8 because it's actually the whole compound ion that needs to be multiplied. Okay, then to balance, we have 3 magnesium, so let's put a 3 here. Then I've got 2 phosphates. I'll put a whole 2 in front here. Then I've got 6 plus, I've got, if we look carefully here at the hydrogens and the magnesium hydroxide, 3 times 2, so 6 hydrogens, so 12 in total on the left. And I've got only 2 here. So if I put a 6 here, that'll give me 12. Then that leaves me with oxygen. I've got a total of 2 times 4, so 8, plus, again, 3 times 2, so 6. So I've got a total of 14 on the left. Then 2 times 4, so 8 on the right. And 6 times 1, 6 on the right. So I've got a total of 14 on the left, 14 oxygens on the right. So that balances out. Okay, then going on to a second example. Let's use nitric acid again. Okay, so my salt is going to be lithium nitrate. It's +1 -1, so they cancel out. And this one actually is already balanced. Going on to rule number 4. An acid plus a metal carbonate gives me a salt. Let's actually just write the salt from the get-go. Plus water plus CO2. So rule number 4 has got a different thing. And the reason is because the metal carbonate has an extra carbon in it. So it needs to go somewhere, so that forms the the carbon dioxide. Okay, so let's take sulfuric acid plus a metal carbonate. So let's do sodium carbonate. Then if I make my salts, it'll be my metal and the negative part of my acid. Okay, sulfate is -2, sodium is +1, so it becomes Na2SO4 plus water plus CO2. Okay, checking the balancing. I think this one might just be balanced. Yes, it does look balanced. Okay, another example, hydrochloric acid plus lithium carbonate will give me a salt, water, and CO2. Okay, lithium is +1, chlorine is -1, so it balances out and give me LiCl. Now, whenever I do this sort of type of example, people will ask me, but why does the lithium have a 2 on the left and not a 2 on the right? Now, the 2 on the left is there because of cross-multiplying. The 2 on the right is not there because, again, because of cross-multiplying. So it's not that lithium needs to stay the same and stay 2. If it doesn't cross-multiply and give you a 2, it doesn't, and that's fine. Oftentimes, it will be a 2 on the left and not a 2 on the right. Going on to your last rule, we actually need to go back and balance that one quick. So if I put a 2 here and a 2 in front of the HCl, that should be balanced. Let's check the oxygens. There's 3 on the left, 1, 2, 3 on the right. That should be balanced. Okay, rule number 5. Ammonia plus an acid gives you an ammonium salt. So ammonia is NH3 plus an acid, for example, HNO3, gives you an ammonium salt, so NH4NO3. So ammonium, remember, is NH4 plus 1, and the salt will be this, and then the negative part of the acid again. So it's ammonium nitrate. This is +1, -1, so they cancel out. Remember to erase those that working for the +1, -1, otherwise it looks like the compound is charged, when in fact, when you cross multiply, it is actually neutral. Let's do another one. Ammonia plus sulfuric acid gives you ammonium sulfate. Ammonium is +1, sulfate's -2. If I cross multiply, it becomes ammonium 2, sulfate 1. Okay, so those are your 5 rules. Now we just quickly need to talk about, like the live worksheet did, but just to revise or just to recap on it, the exceptions to that rule. So there are 2 funny acids where when I write the acid, or the salt down rather, I write them in a little bit of a strange way. And those 2 exceptions are acetic acid and oxalic acid. Normally, if I write my acid plus my substance, so let's say you've got a metal oxide. Normally I would go, okay, the salt is going to be the metal. Now remember, with acetic acid it breaks up a little bit different, forms CH3COO and a plus hydrogen +1. And remember I said that the salt is always the metal and the negative part of the acid. So my instinct would be to go here, right, Li, and then CH3COO. This is +1, this is -1, they cancel out. But when I do these 2 acids, when you write the salt, you need to write the acid part first. So you're going to go CH3COO Li. Okay, let's look at another one like that. CH3COOH plus magnesium hydroxide. Now, I'm caring just about the salt at the moment, so I'm not too concerned about all the products. Okay, once again, this is going to break up. The magnesium is going to bond with the negative part of the acid, and it's going to form MgCH3COO, but that's not the way we write it. Okay, we're going to write the acid part first, and then the metal. This is -1, this is +2. Cross multiply, this becomes a 2. Remember, it's a compound ion though, so I need to put it in a bracket. This becomes 1. You know we don't write the 1s there, so it becomes that. So, weird one, you write the acid first and then you write the metal. Let's do it for the oxalic acid as well. Okay, so this one breaks up, again a little bit weird. So COO brackets, 2 of them, and H plus. When the COO loses the 2 hydrogens, it becomes 2 more negative. So it becomes minus 2 and then H plus here. So what will happen here is the metal will bond with the, again, negative part of the acid. And again, your instinct is to write the metal first and then the acid. But for this one, remember you swap it. So you go COO brackets 2 Ca. This is minus 2, this is plus 2. So they cancel out and it's just COO bracket 2 Ca. Okay, let's do another one like that. Let's say plus lithium. So again, I'm going to write this part first. It's got a minus 2 charge, lithium's got a plus 1 charge. Cross multiply, and it becomes COO2 Li2, like that. Don't divide by the 2 in this case, because this is literally the oxalate ion, it's what it looks like. So even though it might be tempting to try and simplify this, actually leave it exactly as it is and leave the 2 on the outside there. Then part of your homework obviously was to complete worksheet number 1, which was the acid-base reactions. So we're just going to go over them quickly together. So your first one says hydrochloric acid plus magnesium. So hydrochloric acid and a metal. So it's an acid and a metal. And that always forms a salt. Your salt is going to be MgCl and then plus hydrogen. Now Mg is plus 2, Cl is minus 1. So it simplifies to MgCl2. Okay, then we need to balance. If we put a 2 in front here, it should balance. The next one is a metal and an acid. So it's a salt and water and hydrogen, sorry, not water. Okay, zinc is a transition element, but it's one of the few we need to know the charge of. It's plus 2. So this is plus 2, this is minus 1. So you cross multiply and it gives you that. Then to balance, if we put a 2 here, that should balance out. The next one again is an acid. This is all rule 1, you'll notice. Acid and a metal, it will give you a salt plus hydrogen, and that should be balanced. Calcium is plus 2, sulfate's minus 2, so they cancel out. Next one is an metal oxide and an acid, so it gives you a salt and water. To balance, we should just put a 2 there. Okay, next one again is a metal and an acid, a metal and a metal oxide and an acid. So it will give you a salt and water again. Okay, notice how difficult these would be if I didn't know my compound ions. If I didn't know nitrate was minus 1, sulfate is minus 2, carbonate is minus 2, hydroxide is minus 1. It's so crucial. That's why next time I see you, I'm going to give you a little spot test on the compound ions again. Okay, the next one, metal oxide plus an acid gives you a salt. I've cross multiplied immediately, and water. And if I put a, no, this one should actually be balanced. Next one is rule number 3. A metal hydroxide plus an acid will give me a salt, which is the metal on the negative part of the acid. Let's write it on the left-hand side rather. Plus water. If we put a 2 here, that should be balanced. No, it should not, because there's 2 plus 2, so 4. We need to put a 2 there, and then I think it's only balanced. Next one, same rule. So we're just going to go straight into the salt and water. If we put a 2 there, that should be balanced. The next one is an acid and metal carbonate. That is rule number 4. It'll give me a salt. So calcium is plus 2, nitrate is minus 1, so it gives me this in a bracket 2. Plus water, and careful of this rule, you also, when you have a carbonate, you also form carbon dioxide, because that carbon needs to go somewhere. If we look at it and you forget that,